Hello everyone, I'm Eric. Welcome back to my channel. In this lesson, we are going to talk about transition stability analysis in ETAP. And I already draw a single line diagram example here, and I will show you how to set up these parameters. So first of all, you go to this generator first, go to rating, and you put 10 megawatts and 11 kV here, and you go to impedance and model. Let's just put typical data here. Don't forget to put damping 10 here. So then let's go back to rating. Let's go back to information. And remember, this one is PV bus. So you put voltage control here, and then you put OK. After that, we go to bus 1, nothing special here, 11 kV, and then we go to transformer 1. Transformer 1, you go to rating. Uh, uh, this primary side is 110 kilovolts, and secondary side is 11 kilovolts. So you put typical data here and also typical value here. Nothing special, and you press OK. And part 3, you don't need to set up. It will automatically generate 110 kilovolts after you put the transformer parameter. And then we go to a transmission line cable here. Parameter. You choose the conductor library you need. For me, I choose TNB book, and also this one in my study case, and then you press OK, and you go to configuration, and I put the height 50 feet, and spacing you put 3 here, 3 here, and you will automatically generate 6 here. Like if I put 4 here, you will automatically generate 7. So I put back 3. Okay. Transmission line. After we finish transmission line, we'll go to this load. So you go to nameplate, and yeah, just put rating MVA here, and then you put a power factory here. You will automatically generate rest of the stuff. Okay, same here. So I put 7 megawatt, 7 MVA and 90% power factor here. Then press OK. Also, let's go to bus 7. You will automatically generate 110 kilovolts, and then let's go to a transformer 2. Let's go to transformer 2. Quite similar compared to transformer 1. You just put 11 kilovolts here, 110 kilovolts on the secondary side, and also rated 12.5 MVA megawatt, and you put typical here, and also typical value here. Okay, nothing special. And bus 5, you don't have to move it. And generator 1, generator 2, be careful here, because we already put PV bus on the generator 1, so we need a swing bus, or you can say reference bus in other word. So we put swing bus here, and rating, no, we go to rating, we go 10 megawatts, 11 kilovolts, and everything here. And so we go to impedance and model. So all I want you to do expect typical data is that you put the damping value 10 here. Then okay. Then we go to powerful analyze as usual. Every time you do any other kind of analyze like short circuit or arc flash or any other stuff, you have to do load flow analyze first to make sure there aren't any alarm or rolling. So we go load flow and we go run load flow here. It takes a while, and you make sure everything is fine. Then we can go to our topic today, transition stability analyze. So after we finish here, then we go to edit study case event. I already create an event here, but I can just delete and show you how to create it. So, for example, we want to simulate this case in 10 seconds. Sorry. We want to simulate this static case in a very short period, 10 seconds. Then we can add some event happen during this period of time. So we go Q1 first. Maybe something happened on 1 second. Then you press OK. Then you can edit what will it happen. You can do like generator. You start a generator, or you lost excitation or something like that. But I just want to make it simple today. So I go to a bus. Where's bus? I go to bus here, and I go to bus 1, and I simulate three-phase fault, and I press OK. Then I add another one, which it's Q2. It's probably 1.1 second. And then I have to edit this event. So I go to same here, bus. I assume that this fault will be clear in 0.1 second. So I go to the same bus 1 and clear fault. Okay. Then you press OK. Bus 1. We check again. The device is a bus, and it's a PV bus, and device ID is bus 1 and three-phase fault, and go there, same bus, same device, and we clear the fault. So everything should be fine. Oh, don't forget the port. So let me plot here generator 1 and buses, plot all of the buses. Okay, then you press OK. Then we can start our transient stability analysis. So you can see here, run transient stability here. So it takes a while to run this study case. And you can see the action list here. You can just jump to the next event. Just click this one. Then you can see there is a three-phase fault happened on bus 1 on 1 second, and you can also see the event happen on 1 second. Then we can jump to a next transition stability action. Then the fault has been cleared on 1.1 second. So you can see our power flow back again. So after that, you can do some transient stability and pros. So you click this button, and they will make some very beautiful drawing for you. So let's go here. It takes a while. Something happened, so I press one more time. Okay, as you can see, we have ETAP Plots Manager here. So uh, let's see the generator one, which is on the PV bus, on the generator one on the PV bus here. So let's see. Okay, now we can see the power angle and everything you want. Let's see speed and also probably uh, probably current. And you just click plot, then the power. The ETAP plot manager will plot this really nice diagram for you. So as you can see, the faults happen for on 1 second, and then the power angle just dampen a little bit until probably 5 seconds. Then we go back to the normal angle, and you can see the speed from 1800 RPM increase and damping here, then go to a stable status. Then here current, if on a usual status, the currents will be 500 amps, and then it suddenly go up to 2000 amps, and then after the fault's cleared, it dampen a little bit and then go back to the normal. So let's see what happens if this system is unstable system. So I close the plot manager first. So if it is an unstable system, it means that the damping value will be 0. So there aren't any resistance or uh, damping in this system. Let's see what will happen if you change this damping value to 0. And also change this one. So this is an unstable system, as you can see. So then we go to run transient stability again. Okay, finished. And same here. You can see event action list here. So on the first second, on the 1 second, the three-phase fault happened, and on 1.1 second, the three-phase fault have been cleared. And then what happened during this period of time? Let's see same plot in different scenario. So let's go to transient stability pros again. So as you can see, uh, let me just use auto scale. So as you can see here, the plots just go to abnormal. In this case, you see the power angle. It kept damping, and it seems like entities, and also the speed also damping a lot, and you can see the current when it falls clearly, and it kept damping instead of go back to the stable status. So this is differences between stable and unstable system. So when you are doing a transition stability analysis, you have to always consider about generator damping. If it's this if they are able to go back to the normal status or not. So this is about the transition stability analysis. I hope you like this video. If you like my video, you can just subscribe, and I will keep updating these courses. Thank you for your listening. I'm Eric. Have a hope you have a nice day. Bye bye.